Hi there, Mr. Sutton bringing you the IM 2-3 Honors 3-3 homework answers on polygon angles. For number 1, we want to find the sum of the measures of interior angles for a dodecagon. So we'll use our interior angle sum formula, n minus 2 times 180 degrees. So n in this case, since we have a dodecagon, that's a 12-sided figure. So we've got 12 minus 2 times 180, or 10 times 180. Which we don't really need a calculator. This is just going to be 1,800 degrees. For number 2, we're trying to find the sum of the interior angles of a 14gon, which doesn't really have another special name. So we'll use n minus 2 times 180 for this one. So 14 minus 2, which is 12, times 180. We'll get the calculator out for this one. And plugging that in the calculator, we get 2,160 degrees. For number 3, we want the sum of the interior angles for a 20gon. So we'll use n minus 2 times 180 for this. That'll be 20 minus 2, or 18 times 180. Calculator time. So 18 times 180, that'll give us 3,240 degrees for that one. For number 4, we're given the sum of the interior angles of a polygon, and we want to know which polygon it is. So we need to figure out the number of sides. To do this, we'll set this equal to n minus 2 times 180. This is the formula for the sum of the interior angles. Dividing both sides by 180, we have n minus 2 equals 4. Adding 2, we get n equals 6. So a 6-sided figure, that's going to be a hexagon. For number 5, we want to know what kind of polygon has 2,340 interior degrees. To figure that out, we need to know how many sides. So we will set this equal to n minus 2 times 180 to figure that out. And then we'll solve for n, the number of sides. So dividing both sides by 180, let's use the calculator for that part of it. 2340 divided by 180 comes out to 13. So n minus 2 is 13, meaning n is going to have to be 15. And there's no special name for a 15-sided shape, so we'll just call it a 15gon. For number 6, we're trying to find this missing angle in this weird-looking polygon. So strategy on this one, we're going to use our interior sum formula to figure out how many degrees this thing should have inside, and then we'll add all this up and figure out how many degrees we currently have. So we'll use n minus 2 then, times 180. And the n here, the number of sides, let's see, we've got 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 is 4, times 180 is going to be 720. So we'll just add all this stuff together now and set it equal to 720. And we've also got this 90-degree angle in here. Don't forget about that one. So we have 90 plus x plus all these other angles. What does all that add up to? Well, I'll ask my calculator. So I've entered all those numbers on the left side into my calculator, and that adds up to a total of 570. So we've got x plus 570 equals 720. Subtracting 570, x then must be 150 degrees. For number 7, we're trying to find the value of x. Let's start by figuring out how many interior degrees this shape should have. So we'll use n minus 2 times 180 for that. We've got 5 sides, so that's 5 minus 2 times 180. So 3 times 180 then is going to be 540. Let's add all of this stuff up now and set it equal to 540. So combining like terms, I've got 5x, and then for the numbers, let's see here, we've got 86 plus 64, that's going to be 150, plus another 110 gives us 260. Subtracting 260 from both sides, that's going to be 280. And then dividing both sides by 5, that's going to be, let's see, 56? Is that right? No. Oh, no, wait, yep, that is right. Okay. Yep, 56. For number 8, we're trying to find this x value on these exterior angles. The key on this one is to realize that all polygons have an exterior angle sum of 360. So if we add all 4 of these together, it should all add up to 360. Let me use the calculator to crunch the numbers on the left here. So we've got 78 plus 106 plus 65 comes out to 249. Subtracting that from both sides, we get x equals 111. For number 9, we're trying to find the value of x on these exterior angles. We know that the exterior angles of any polygon add up to 360, so we just have to add all of these angles together and set it equal to 360, like so. All right, combining like terms on the left side, we have a 2x, and whatever all these add up to, I'll do that on the calculator. So all that gives us a grand total of 254 on the left side. Subtracting 254, we've got 106 on the right. And then dividing by 2, that's 53 for each of those x's. On number 10, we're trying to find these missing x values. We know the exterior angles always add up to 360, so we can write x plus 2x plus 93 plus 75 equals 360. Combining like terms, we've got 93 and 75. That's going to give us 168. X and 2x gives us 3x. Subtracting 168, that's going to be 192. And then dividing by 3, let's see here, that's going to be 64. For number 11, we have the measures of exterior angles of a quadrilateral being 90, 10x, 5x, and 45. We want the measure of the largest exterior angle. Before we can figure this out, we need to know the value of x. So we need to set up an equation that would let us solve for x. Well, we know that the exterior angles always add up to 360 degrees, so we can add all these together, set it equal to 360. Combining like terms, I've got 15x and 135 on the left. Subtracting 135, that'll be 225 on the right side. And dividing by 15, we have x equals, well, 15. All right, so we're not done. We actually need to figure out the largest exterior angle. So it's definitely not going to be 5x because there's a 10x, which is going to be bigger. What's 10 times x? Well, 10 times 15 gives us 150, and that's larger than the other two angles that we know. So 150 is our answer for this one. For number 12, we want the measures of an interior angle and exterior angle of a regular octagon. Now, they said an interior angle and exterior angle because they're all going to be the same angle since it's a regular polygon. So we just need to find one interior and one exterior angle. I always think it's easier to find the exterior angles first because we always know that those add up to 360. There's 8 exterior angles because we have an octagon. So to find one exterior angle, we've got 360 divided by 8, which I happen to know is 45 degrees, but you could do it on a calculator. So now once we've got an exterior angle, every exterior angle is supplementary, adds up to 180 with its corresponding interior angle. So to get the interior angle right next to this exterior angle, we just have to do 180 minus 45, which gives us 135. For number 13, we want the value of n for the regular n-gon described here. So this is an n-gon where each interior angle has a measure of 156 degrees. Now, the easiest way to do this is figure out what each exterior angle is, and then divide 360 by that number. So if we have 156 for the interior angles, that means each exterior angle is going to be 180 minus 156, or 24 degrees. And we know that the exterior angles always add up to 360 degrees for any polygon, so 360 divided by 24 would give us our answer, and we can do that on the calculator. So plugging that in, that's going to come out to 15. So that means we have a 15-gon here. For number 14, we want to figure out the value of n for this n-gon. This is a regular n-gon where each exterior angle is 9 degrees. This is actually an easier one than if they give you the interior angles, because you know what all the exterior angles add up to. They always add up to 360. So if we just do 360 divided by 9 degrees, we're going to figure out how many of those exterior angles there are. That's going to give us 40, so this is a 40-gon they threw at us.